So hello and welcome. I hope you are having a marvelous and depending on where you're located, a safe day. I'm your host, Charles Collegy, the security analyst for Accelerated Strategies Group. Now today's DevOps.com webinar on getting your innovation flywheel spinning is brought to you by Amazon Web Services and Systig. Today, I have with me Serge Shevchenko, a partner development manager at AWS, Shakti Dakuri, a senior partner solutions architect at AWS, and Eric Carter, director of product marketing at Systig. Guys, please say hello to our audience so that they can get to know you a little better.
Sure.
Hey guys, good to have you all.
Hey guys.
Thanks, Charles.
All right. So I know you want to jump into today's content about how AWS and Systig can help focus on modernizing DevOps to gain speed, agility, realize cost savings, and of course, improve security when you're developing business applications. However, before we get started on that journey, I must take care of the housekeeping items. So please note this webinar is being recorded. So later it will be available on demand. You will receive an email with the link, but at any time you can go to DevOps.com and gain access to this and all of the archived on-demand webinars we have available. So in the near future, peruse over to DevOps.com, take some time and look at our webinar library. Now, a few comments on the big marker platform. First, on the right-hand side of the screen, you'll see the chat button. This feature allows everyone online to interact with us. The audience can interact amongst themselves, and you can reach the speakers. So we want your feedback. We want to know comments. Give us some issues that you're dealing with. So we want to hear with you to make this event most important to you. Now, we ask that questions be not put into the chat because as the chat scrolls with new comments, the questions can be missed. So it's best to use the Q&A window. So the Q&A tab is immediately to the right of the chat tab. Now, when we get to Q&A, we will try to answer as many of your submitted questions as possible before the end of today's session. Now, if we're not able to get to them, I'm sure that AWS and Systig will follow up. You'll also see a handout button all the way to the right. This is where you can download a Systig brief on unified security and visibility for AWS. Now, I do suggest for better viewing that you consider the full screen view, and this can be accessed by clicking the two opposing arrows on the right-hand corner of the screen. Now, for the most important housekeeping item, at the end of today's webinar, we will be awarding 4 $25 Amazon gift cards. So please stay with us till the end to see if you are selected. So now it's time to jump in today's session. Serge will be hitting lead off, so the forum is now yours.
Charles, thank you so much. And good to be with you all again. Very excited for my first webinar with Eric and Shakti. It's been a long time coming.
I got a quick reminder, though. Can we start with our
Sure.
poll so that we can understand who the audience is today? I think that would be a good idea, right?
Absolutely. Let's do it.
All right.
Cool. So I'd like to set the stage here.
Oh, here we go.
Okay, perfect. If everybody can see that, you can click on it.
So we're just asking what your primary role is. Are you in DevOps, security, cloud, a regular developer, a business application, or something other? Gives Serge and Shakti and Eric some good ideas on where we are. So we'll just take another minute to put that up there. And unless you guys want to just give a little more background about yourself while this poll is up.
Sure, let's do it. So I'll start on the AWS side. By the way, it is really cool to see the primary roles just being very, very equal. So I think everyone's in here for a treat. So as Charles had mentioned, my name is Serge Shevchenko. I am a global startup partner development manager here at AWS. Been with AWS for about 3.5 years now. I cover and I get the privilege of working with some of our hottest startups, particularly in the developer tools segment. So I get to work with Sysdig among a few others. And with me, I also have Shakti. Shakti, if you want to introduce yourself.
Hey everyone, I'm Shakti Dakuri. I'm the Partner Solutions Architect at AWS. I've been here for about a year now. Looking forward to talk to you all.
Yeah, and hey guys, I'll just go ahead. This is Eric Carter. I'm with Systig. I'm really part of the product marketing team, and I get the privilege of focusing that role on our partnerships, and of those, AWS is chief. So we're pretty excited to be able to present together, which we don't always get to be able to do. And part of why we're asking who you are is just to give us a level set and know the audience that we're speaking to. And as Serge, you said, like there's a pretty even split. We have some business partners, folks that are more development, and so on and so forth. IT ops, I think have something for everyone at the end of the day. So I'm going to go off camera, and I think you can take it away, Serge.
Cool. Perfect. So as I alluded to earlier, I'd like to really set the stage today by covering what we call Innovation Flywheel concept, which, by the way, I believe about 20 years ago, Jeff Bezos sketched it on a napkin. And the idea is simple, really. A flywheel takes a lot of effort at the start, but once it gets spinning, it continues to gain momentum and spin faster and faster. The concept that Jeff sort of sketched on that napkin was really alluding to areas of Amazon's business that we are going to invest into that'll catalyze our momentum. And today, I'd like to start things off by really alluding this concept to how it relates to DevOps. When applying the innovation flywheel concept to DevOps, our expectation should be that the outcome of this process and practice is to deliver business value at, again, a more rapid rate. We shouldn't be looking at DevOps as a team or a project. It's fundamentally changing how you deliver software by changing culture, processes, and using the right tooling to get the job done, which we'll talk about a little bit later today. In order to achieve that agility and build your own innovation flywheel, we need to allow teams to quickly and nimbly experiment, right? And expose new features to a limited set of users and systems, hence significantly controlling the impact radius. The second piece is that is important to the flywheel is make sure that you have the necessary mechanisms in place to analyze ideas and customer feedback as we experiment, creating that positive feedback loop within the innovation flywheel as well. Use that feedback to inspire new ideas. Little fun fact here, about 75% or more features and services developed by AWS come from customer feedback and requests. And again, the goal here is really for innovators to keep this flywheel turning as fast as possible. Diving a little bit deeper, I'd like to discuss what development transformation needs to take place in order to fuel and be fueled by the innovation flywheel. It's the idea of modernizing your monolithic applications over to microservice deployments that are owned and operated by teams that about two pizzas could feed. And I'll talk about this concept on my next slide. But the concept of really modernizing your infrastructure, going from a monolithic application to microservices managed by a size of a team that could be fed by two pizzas, has been in practice at Amazon for a very long time, actually. The issue with monolithic applications is that teams are very fragmented, which microservices and smaller teams which own the entire software development lifecycle, they solve these fragmented issues as well, and we'll dive into that a little bit later. Shared and complex release process, for example, change, build, and compile, package, and test and orchestrate sort of release activity across multiple teams can really slow things down from a software delivery standpoint. Again, this leads to fragile software that scales very rigidly and requires over-provisioning to handle increased loads. And since everything's interdependent, the radius of impact for each change can be pretty wide, and also makes it very hard to adopt new technologies, roll out new features, functions for customers as well, or perhaps even version control. The evolution normally centers around separating and decoupling the monolith into microservices that focus on one thing and do it really exceptionally well. Each microservice often has its own data store and can be deployed and scaled independently. They represent the real world where service boundaries equal business boundaries. You end up with the ability to make decisions very quickly. Because these decisions only impact the individual service teams and applications, this can lead to, and ideally this concept will lead the DevOps teams to rapid incremental innovation versus waiting to take one giant leap. The two pizza team concept means that these single teams own that service and minimize social constraints. There's a great quote by Melvin Conway. It goes like this: any organization that designs a system, which is defined broadly, will produce a design whose structure is a copy of that organization's communication structure. Hence, working backwards, you start with how you want your systems and applications to communicate, and then you create an organizational structure that mimics this. And as you modernize your applications and you reorganize your teams, empower them to run autonomously. And I do want to dive into what that means from an organizational standpoint. In a monolithic approach, again, you have that fragmented development team, and that manage the workloads and deployments and applications. When you reorganize, the intent here is that the microservice teams own everything, or as much as possible. You might ask, how is that possible? I do want to hand it off to Shakti to really break things down for you from a technical perspective. Shakti?
Hey, thank you, Serge. Before diving into the microservices delivery lifecycle, let's quickly touch upon the monolith one more time. With monolith, basically, there's only one single pipeline. One developer is holding back other developers, and the entire cycle slows down. Like Serge mentioned already, there are benefits of getting reorganized. And when the application architecture and the teams are organized to run at scale independently, this is what your delivery lifecycle looks like. Multiple two pizza teams on the left side deliver updates in parallel and have individual pipelines delivering changes to production. Each pipeline has its own planning, development, deployment, performance, bug fixes, and documentation. If you look at it, each service operates independently and leverages API contracts between the services. As an example, Amazon has 190 deployments a year. All of this is possible only because of the microservices delivery in parallel. If you're interested to learn more about how Amazon DevOps pipelines works, you can refer to Amazon's Builders Library articles such as Automating Safe Hands-Off Deployments. Moving along. So before we talk about containerization, let's take a step back and take a quick look at the journey, which starts with physical machines, which is also known as bare metal. You own the software, you own the hardware, your entire stack. You own CPU memory, you have to configure networking, you own the networking, power, operating system patching, performance optimization, high availability, among others. If you go a little bit of higher in the abstraction, we have virtual machines, which has easy administration, optimized for best use of hardware resources. But again, you have to manage the physical hardware. A little bit higher in the abstraction layer, we have containers, which is highly scalable, distributed in its architecture, but still you'll need to maintain the hardware. As you can see, as the level of abstraction increases, you're able to focus more on the business logic. With that, finally, we have serverless. With serverless, you do not maintain any hardware, no OS patching, no upfront hardware resource planning required. You are able to focus on the business value. It is fault tolerant, you pay for the value, and it's highly scalable. Diving a little bit deeper in containers, let's look at the AWS container landscape. There are three groups of services in this. First one is registry, then orchestration and compute. Let's start with the first one, registry. The service is Amazon Container Registry, which is a fully managed container registry that makes it simpler and faster for developers to store, manage, and deploy container images. Then we have, in the orchestration layer, we have Amazon ECS, or also known as Elastic Container Service, which is a fully managed container orchestration service that provides most secure, reliable, scalable way to run containerized applications. It deeply integrates with the rest of the AWS platform to provide secure and easy to use solutions for running container workloads in the cloud. Next, we have Amazon Elastic Kubernetes Service, or EKS, which is a fully managed Kubernetes service that provides most secure, reliable, and scalable way to run containerized applications using Kubernetes. EKS runs upstream Kubernetes and is also certified Kubernetes conformant for predictable experience. You can easily migrate any standard application to EKS without needing to refactor your code. Next up in the compute layer, we have Amazon Fargate to start with, which is a serverless compute engine for containers that works with both Amazon Elastic Container Service and Amazon Elastic Kubernetes Service. Fargate launches and scales the compute to closely match the resource requirement you specify for the container. Diving a little bit further on Fargate, with Fargate, you get out-of-the-box observability through built-in integrations with other AWS services, including Amazon CloudWatch Container Insights. Furthermore, Fargate is secure isolation by design. Individual ECS tasks or EKS pods each run in their own dedicated kernel runtime environment and do not share CPU, memory, storage, or network resources with other tasks and pods. This ensures workload isolation and improved security for each task or pod. Finally, we have the Amazon EC2. Amazon EC2 gives you full control. Run containers on virtual machines with full control over configuration and scaling. Moving along now, let's talk about CI/CD, or also known as continuous integration and continuous delivery. CI phase has source, build, and test stage, and the CD has deploy and monitor stage. Closing the loop by fixing any bugs found in the monitoring stage and repeat the cycle for bug fixes, enhancements, and new features. In the source stage, tools such as AWS Code Commit, Git, etc. are used, leveraging version control and branching strategies. All changes going to production start with a code review and must be approved by a team member before merging into the main branch, which automatically starts the pipeline. Next, in the build stage, we have fully automated pipeline based on PR, compiling build artifacts and run integrated unit tests. Post-build stage, we have the test stage, where we run integration tests with real endpoints of other pre-prod services, and sometimes a small load testing is included as well. Other test suites such as load test, security test, acceptance test, performance tests, etc. are run in this test stage. In the deploy stage, software deployments are fully automated, allowing you to deploy reliably and rapidly. You can consistently deploy your applications across your development, test, and production environment. As an example, AWS Code Deploy is a fully managed deployment service that automates software deployment to a variety of computer services such as Amazon EC2, AWS Fargate, AWS Lambda, and your on-premise servers. In the monitoring stage, production and staging environments are actively monitored using services such as Amazon CloudWatch and X-Ray. And alerts are generated using services such as SNS Simple Notification Service, SES, which is Simple Email Service. Moving along, let's talk about the DevOps best practices with the summarizing. First up, we have continuous integration, which is a software development practice where developers regularly merge their code changes into a central repository, after which automated builds and tests are run. The key goal of continuous integration is to find and address bugs quicker, improve software quality, and reduce the time it takes to validate and release new software updates. Next, we have continuous delivery, which is also known as CD. CD is a software development practice where code changes are automatically built, tested, and prepared to release to production. It expands upon the continuous integration by deploying all code changes to testing environment and or production environment after the build stage. Next up, we have microservices. The microservices architecture is a design approach to build a single application as a set of small services. Each service runs on its own process and communicates with other services through a well-defined interface using lightweight mechanism, typically an HTTP-based application programming interface, or API. Infrastructure as code is a practice in which infrastructure is provisioned and managed using code and software development techniques, such as version control and then continuous integration. The cloud API-driven model enables developers and system administrators to interact with infrastructure programmatically and at scale, instead of needing to manually set up and configure resources. Next, we have logging and monitoring. Organizations monitor metrics and logs to see how application and infrastructure performance impacts the experience of the product's end user. Finally, teams set strong cultural norms around information sharing and facilitating communication through the use of chat applications, issue or project tracking systems, and wikis. This helps speed up communication across developers, operations, and even other teams like marketing and sales. With that, I'll hand it over to Eric, who will talk about Systig and how it can complement AWS services and helps it with visibility, security, compliance, etc. Take it away, Eric.
Great, thanks, Shakti, and thanks, Serge, kind of getting us into the topic, and I'll kind of clean up here. I want to focus a little bit on the finer point of, as you're moving down this sort of DevOps practice, kind of retooling for it, getting kind of your apps developed in this way, what kind of role does security play, and what can you anticipate? We're going to look at some of the challenges, things to anticipate, what are some of the approaches, and if you're not already thinking about some of these, to maybe get them on the docket in terms of trying to apply them to what you're up to with your teams. So we're going to start with just the concept of, answering the question, what slows down DevOps? And there's a report out by the firm 451 Research, and look, one of the things, and it's really no surprise that they found that security and compliance end up being the biggest barriers to adopting this new way of being, this new way of rolling out applications. And we'll talk about some of the reasons why in just a second. But, at the end of the day, we get excited about delivering apps in this way. But if we wait to address security till the end, that's oftentimes where things get stopped. Why? Because the security-focused folks in the organization, which there are many on the call today, will come and say, did you address these things, right? So that's one thing to think about, right? As you're adopting DevOps, you've heard the term DevSecOps, right? And this concept of secure DevOps, it's a real thing, right? We need to make sure that we all wear a hat of security pretty much at all times. Now, the other things that the report found, which goes back to what Serge talked about, as well as Shakti, is that there are other just cultural things that kind of have us resisting or slowing us down, resistance to change. That's not the way we do things. This sounds a little hard. I don't know if I want to, right? That can be an issue. Or maybe you're just got different teams that want to jump on this quickly and are now competing in terms of priorities. At the end of the day, communication between teams can be an issue. And that is, is a security team, do they own that, or does the DevOps team own that, or what about the storage guys and the server guys and so on and so forth? So the idea is hopefully that we break this down. The two pizza team concept is, hey, why don't you try and own the entire stack from cradle to grave, and that would be great. Easier said than done in some cases, but worth the effort. Now, the other thing here is that other than being slowed down, if you're not thinking about the security equation, worse things can happen than just slowing your delivery, right? And that is things like breaches, right? And the numbers here come from a couple different reports. It really is, even though it's shocking, like 90% of organizations have experienced a cloud breach. On the other hand, it's not. And it's not because these can be large and small. And you see that people around the world, hackers are trying to just test and get into things, right, all the time. And maybe that kind of thing has happened to you. So 98% of folks report that that's happened to them in the past 18 months. Again, could be large or small. Now, one of the key challenges, the middle stat here, is that sometimes the thing that happens today, we are not going to figure out that happened until St. Patrick's Day, right? So if it takes us 247 days to understand that something happened, we also need to make sure, and we'll talk about how ways to do this. We all need to make sure that we're preserving records that help us uncover the what happened, even if it happened last year. And last but not least, we don't want to lose money. We don't want to have the impact of over $4 million on account of a data breach. We see the big stories in the news. There are ways to prevent this, or to at least reduce the risk of this. And so we're going to talk about how to do that. So what are those risks? And we've put them here into two buckets. You may own one, the other, or both of these, depending on how advanced you are in terms of your DevOps approach. When we think about workloads, and let's put it in the context of containers as an example, containers and Kubernetes. We're grabbing containers out of a repository or registry somewhere, and there may be known vulnerabilities in there. That, in fact, I can guarantee there will be. The question is, are you checking what those are? Are you checking the severity of those? And are you remediating those as you go? It's important to do. We don't want those in production. So that's a risk. And then there are some things that no matter how many times we scan the code, we scan the image, we're just not going to be able to detect with that tool set, but we want to watch for behavior, oftentimes human behavior of people trying to get into our systems during runtime. So we have this app up and running, we got our services or microservices. Can we understand what's happening? And then if something does happen, to my point on the previous slide, do we have an audit trail? Do we have an audit trail that will help us, whether it's help us answer the call to an auditor for compliance, or whether it's just trying to do forensics on something, right, to understand the what happened. On the infrastructure side, and I always tease the guys at AWS, you make it so easy to go and access a service that in many cases we end up with people accessing these things and spinning them up, and we may not know about them as a broader sort of well-managed and governed organization. So do you know what things are being used? Are they configured correctly? And is there risky behavior going on? Sometimes it's accidental, sometimes it's guys like me on the marketing team that went and spun up a database or something just because I'm trying to do something, but maybe I didn't configure it with the right kind of permissions. Does that put us at risk? Or maybe it's worse, right? Maybe it's something more malicious than that. But the question is, if these are risks, what are you doing to also address them along the way? Now, addressing them has been a little bit complicated for teams as they enter into this modernization journey. Why is that? Because some of the technology and the abstractions that we're using, everything from containers to infrastructures, code, and so on, can mask visibility that we had kind of tackled in our more traditional environments, things like virtual environments, right? So the question is, as you roll these things into production, are you able to see the behavior? Do you see the performance? Do you see the health? And containers can block that. So you need to find ways to solve those challenges. Systig helps do that, of course. And so that's one challenge that you'll need to address if you haven't already. Now, context, the middle one, is also very important. I mentioned the word abstraction, right? So now we may have clusters running across different regions, and we may have different things that happen. But the question is, can we get down to it? What cluster, maybe what namespace, down to what container, where is it happening, and so on. And so you want, when you're uncovering, when you've got that visibility, you understand what's happening and got metrics, you've got telemetry, you want to pair that and enrich that with the data, the kind of almost like the map of where it happened, right? And so not every tool is going to be able to deliver this to you in sort of the DevOps context. So it's another thing to think about and to tackle if you haven't already. And the last thing is, especially in the world of containers, which Shakti talked about, EKS, ECS, and all of the things with like Fargate and otherwise, if a container spins up, runs, does something, and then stops, which is very common, can happen even, can run for less than 10 seconds in some cases, right? Did something happen there? Do you know what happened? And have you stored that as evidence for the later on possibility that you need that information? So again, easier said than done. So think about these as the challenges that you want to solve. And so just a couple more things for me. Let's spend a little time on this, which is just going to look at this life cycle. So everything from the developers who are coding, and I know we've got some of you here, and coding and then building and maybe pushing it through a CI/CD pipeline. You've got the ops folks who are with us who now have to run this thing, or again, maybe it's a pizza team, you're doing all of this, and then something happens, and how do you respond? And then how do you feed that back into the loop? Now, again, we're going to focus here on security across this chain. There are tools that can help you in each one of these places, but how do we pair that with the right level of security? Let's start at the left. So infrastructure as code, Shakti mentioned it. I mean, now we have these manifests and YAML files and other things where we're defining templates for how we want to interact and roll things out onto the infrastructure. So are you able to understand that there, what's kind of the best practice versus, otherwise around those templates? So there are tools in the market, and it's something that Systig is now stepping into with an acquisition we did of a company called A-Policy, which closed this week, to scan those things and look for common or known misconfigurations or risky configurations. And then later we have this concept of drift. Things might get like shifted and changed, and how do you roll that back and remediate that? So that arrow underneath, in all cases, we want to be able to get that feedback, again, that kind of CI/CD, and keep fixing and keep advancing and keep innovating, right? So securing those things, infrastructure as code, securing the images that we're rolling into the CI/CD pipeline or through the registries. How does that happen? We want to be able to scan those things, look for known vulnerabilities, and fix the ones that are going to cause us issues. We don't know of any company that fixes everything, and that's why they're rated like low, medium, and high. Clearly, we want to fix the high vulnerabilities, address the medium ones, the ones that make sense, and then we can move on from there. But you can now do this so that a developer using something like, Jenkins as a CI/CD pipeline can, within that tooling, see what are the things that have been discovered, what are the things that I should address, are there fixes available, and let me do that before I push those out. Now, once we get into this run phase, if we're running on something like the AWS cloud and an EKS cluster, we want to be able to understand, Serge and Shakti and Eric, are they logging in with the right kind of permissions, or is someone else logging in? Can we understand that that's happening? And while that's happening, is something else taking place so that we can understand the chain of events that are happening? So there's this concept of what's your cloud security posture. And you can get a lot of great information out of things like AWS CloudTrail. One of the things that Systig done is implement a rule set and policies to where you can continuously check those things to look for anomalies, to look for best practices, to ensure that you're in compliance with whatever standards you need to meet, PCI, NIST, and so on and so forth, and just to make sure things are secure. And again, you want to be able to detect things that are happening inside of a container, even a container that runs for less than a minute, right? And look for compliance violations. Hey, there's certain directories and data that should not ever be touched, or these containers should never run as root. We can understand and detect those things and help you to remediate those things by giving you that feedback loop. And then last but not least, look, things are going to happen. A lot of bad things happen in the world. and across our systems that we're rolling out. We want to be able to respond quickly. So again, capturing data and information that you can store. Some folks are doing that out of CloudWatch with AWS, capturing different things like logs. And with Systig, one of the unique things that we do is let you take what's essentially a syscall capture of everything happening at that location where the thing was triggered an alert, capture that, store that, and now you have that information so that you can understand and do forensics on what happened, right? So each of these steps are important to think about the security equation. Each one of these places has a tool set that can help you. And at Systig, one of the things that we've done is try and pull a lot of this together so that you don't have to be running from tool to tool to understand what happened. And that brings us to that. I just want to give you the picture of who we are, what we do at Systig. We call what we deliver the Systig Secure DevOps platform. You can think about that as having a couple of pieces. One is the security lens, what we call Systig Secure. One is more of the monitoring lens, meaning more of the performance and health. And what's interesting is that having these things together will help you oftentimes, because the security thing may show up as a blip on the radar, or CPU utilization or memory or something breaking down in that form. And then you come to find out that someone has entered your system, and we want to stop that, right? So think about the categories here. We can help you secure the build pipeline, scanning the infrastructure as code, the container images, looking for those things that will cause you grief or cause risk to your organization. We can help you detect and respond to runtime threats. You see in the center of the circle there, a lot of what we do is based on on open source projects. Falco and Systig are both started by Systig. Falco is now a part of the CNCF, but we also leverage things like Prometheus and Cloud Custodian. And the goal here is to innovate and quickly by leveraging community contributions and things like that. But Falco is a big piece of helping you detect and respond to what's happening while things are running. And that's something you can start with as an open source project. And what we've done at Systig is built on top of that, more of a SaaS platform, a UI that lets you very easily set things, help you communicate across teams, set up roles and those kind of things. And now we're tying into things around AWS, CloudTrail logs, and so on to help you manage that security posture. And what we try to do is spend some time understanding, like if you are dealing with credit card information, for instance, and you're subject to the PCI standard, what are the rules and what are the things rules you need to put in place, or policies, and the things you need to monitor in order to give you the best kind of leg up to be PCI compliant in a cloud, in a container, in a Kubernetes environment. So one of the useful things is that we give you kind of those, I'll call it a blueprint on each of these aspects, from the build pipeline to the runtime and so on, and the cloud security posture management side, that will help you easily set those things up and keep an eye on them. And then last but not least, as I mentioned, part of what we do is help you give you, data, events, telemetry, metrics with context of the cloud that it happened in, the region of that cloud that it happened in, the cluster, all the way down to the process level of what's happening in a container. You can imagine that's pretty useful, and we can do that without having you to put any Systig code inside of the container itself, which would be contrary to best practices. So think about whether you've addressed each of these areas, and if you haven't, we would certainly be glad to have a conversation and help you with that. One of the customers who's done this with us, leveraging AWS, leveraging Systig, leveraging both kind of, we would call it hybrid cloud, on-prem as well as public cloud, is SAP Concur, right? And to go back to the beginning of the story, is their goal was to deliver apps more quickly by adopting this DevOps approach, right? And so managing this growing estate with a very small team meant that they had a lot to keep up with, including things like reviewing code for vulnerabilities before pushing it into production, and doing that on a more manual basis. So they were lacking some of the automation, and that made it even more challenging to do things like meet PCI compliance. So what did they do? They implemented the Systig tooling that I'm talking about to kind of to make sure that they have the security pieces in place along each of those steps. automating vulnerability scanning, detecting things at runtime, monitoring everything, and being able to monitor it all from this single place, which helps save them a lot of time and effort, right? And then capturing things so that they could turn around to anyone asking, auditors, management, shareholders, you name it, right? We are in good shape. This is what happened or didn't happen, and this is how we prevented it, and so on. So the results are, look, they're saving a ton of time by automating, and they put it down to like the hours they save. I don't know how many FTEs this would be equivalent to, but 10,000 hours annually saved by putting the right tooling in place, getting to be scalable, right? So they've scaled since they implemented what they've done with AWS and Systig. They've grown 20 times, and that's just been in like, let's call it 3 years time. And now they're significantly, easing a lot of the work that they have to do, especially around compliance. So hopefully you identify with that kind of story that these companies like yours go through as they start out, and the kind of journey that they're on to try and tackle these things to make sure that they are secure and compliant. So what are the benefits of everything that we talked about today? One, adopting DevOps, adopting it in a secure kind of way, secure DevOps, we call it. You're going to be able to ship applications faster. Why? Because a lot of the things that might stop you and stall you are handled, right? And because those things are handled and you have the right level of visibility, you can address things quickly. So the performance of what's running, the availability of what's running, you'll have a greater handle on and be more efficient in managing. And I think the important one for the story today is reducing the risk, right? So if we have the visibility, if we have the auditability, and we're doing it along each stage, we will be able to confidently run applications and understand that we've done our best to eliminate a lot of the risk. There's always going to be something happening, but we want to make sure we've done our due diligence and made things happen correctly. All right, so that brings us to the very end, where we will pause. We've put some resources here for you to get started. There's a page there that you can read a little bit more about what we're all doing together here, AWS and Systig. You can always go to the marketplace and check out some things there as well for AWS. And then if you're curious about how this would work for you, there are ways to get started without any investment, even a piece that's completely free. So you can go to the URL there, systig.com/start free. So let me pause here. And then Charles, I think we will take a deep breath while you take over for the Q&A session.
All right. All right. Sounds great. And Serge, Shakti, and Eric, I mean, you worked so well as a team, and I picked up some interesting pointers. Kind of that resistance to change and security definitely goes hand in hand, right? And we have to find ways to overcome the barriers, and that's important. In the future, I think it'll be interesting to see how security is tied to policy as code. I mean, that's where things are going in the future. So as the host, I take advantage of asking the first question. And I'm the security guy, security analyst. So I'm kind of curious, just overall, what some specific security threats or breaches that are top of mind. What's most active? What are you seeing the most of right now?
I'll take a start at that one. One of the things, especially when we think about the world of containers, where we've done a lot of work, there's this concept of lateral movement, and what that means is that these hackers are trying to find some way in. So they're trying to gain access, and that's the problem with doing things like running containers as root or that are too permissive, is that if someone can get there opens the possibility of moving deeper into other systems or the network. And usually the way they get in, they don't care about that part. What they want to get is the more sensitive data, info of higher value, gain. And so that's one of the things that we see. And there have been some stories out there. I think sometimes we try and hide exactly what happened and on purpose, but we know of a couple, which I won't cite here, but that's the way that the breach happened. right? They find a way to get in, and then they move somewhere else, right? And so that's one big thing. You know, sometimes it's more simple. It's around somebody didn't configure the web application firewall correctly, and so now someone very easily just got right in, or moving from something like a web portal to internal systems. So there's a number of things that can happen, and oftentimes, you know, there's this look back where folks realize, oh, well, yeah, there was something vulnerable inside that container that we could have or should have known about, and we just simply didn't address it, right? And so that's when they learn the real lesson, and then they start to put more stringent practices in place. You know, the goal here is not, and it's a challenge, right? It's like, oh, well, the security slows us down, but I think once you have something happen, you realize the importance of it. Because I think with automation, you can do it without slowing yourself down. So hopefully that addresses that, at least from one level.
Yeah, I mean, I think you summed it up in part of your presentation. It's all about visibility. When I talk to CISOs, visibility is the word they use the most. So, Suraj or Shakti, anything about the security threats that you're seeing?
So I do want to actually go back to Eric's point here as well. And as important as visibility is, I think some of the challenges that a lot of customers are facing today are they do have visibility to a lot of these security vulnerabilities that partners like Sysdig help them uncover. The challenge now is, from an operational perspective, how do we decide which vulnerability to work on, right? And what we've done in the last couple of months here is we've actually integrated with AWS Security Hub. And, you know, a combination of Sysdig and Security Hub does a really good job of detecting and addressing problems, but also now aggregating some of these findings and helping customers decide what vulnerabilities to prioritize, right? So I think that can accelerate a lot of security practices here.
Yep, perfect. Agree.
Yeah, great. So Carlos has a question, kind of more curious about, is there any GitHub solution for infrastructure as code? They mentioned Argo CD for Kubernetes. Any comment on that specific detail?
I think this is probably, they're asking if there's a GitOps solution, maybe out of the AWS portfolio, guys. I don't 100% know the answer, but I know, yeah, something like Argo CD is gaining a lot of momentum and steam around the Kubernetes space, especially.
We can get back offline on that.
Yeah. I think that's a good one to follow up on. Another question we have, and it kind of comes up, and whenever I'm talking to you, to the AWS guys, I get confused about, you know, Fargate and EC2, and, you know, how do those things work together? Do I decide which one to go for in that environment?
I can take that. Let's start with EC2 first, right? So with EC2, you deploy and manage your own clusters of EC2 instances for running the containers. They are typically used in case where you have high CPU and memory intensive application architectures. Now, if you go to Fargate, you run the containers directly without any EC2 instances. Like I mentioned in my previous slides, there is no hardware to maintain, no OS patching. It's totally serverless. So if you want to get onboarded very fast with containers, Fargate is the way to go.
Okay. So it's more of in the container section.
Yep.
Okay. And what about we follow up with you have Elastic Container Services, and then you have Elastic Container Services Kubernetes. I guess the issue there is one uses Kubernetes for orchestration and the other doesn't, or is it that simple?
Well, yeah.
Yeah. I mean, see, if you in a nutshell, right, both the services support broad area of compute options, and both of them have deep integrations to AWS services, right? But if you look at it, ECS is very simple solution to onboard for anyone, right? AWS does all the heavy lifting when you go with ECS. But if you want to go with EKS for its rich ecosystem of open source, so you want to collaborate and leverage the open source tools, EKS is the way to go for that.
I think about the phrase with what is it? With great power comes great responsibility, or whatever that Spider-Man thing is, right? And it's my impression, and I don't think I'm wrong, but like Kubernetes has a lot more knobs and bells and whistles and things that you can do and tie into, and so but with that comes you have to understand it and know how to leverage it, right? ECS is just very like, hey, I can get a container thing going pretty quickly. Yeah, both have their place.
Okay. All right, great. So we have another question from Tariq, and it's about microservices and how they play a role in DevOps best practices. On one of the slides that I think Shakti might have been discussing, it was on just how the activities between microservices and DevOps kind of best practices play together.
Yeah, I can take that. So if you look at it, agility is the need of the hour, right? And then and in DevOps practices, it is at the core of it. As an example, right today, Amazon is able to deploy 190 million deployments a year. It's all because of microservices. The things that we spoke about earlier, two pizza teams, CI/CD, continuous delivery and continuous integration. Continuous integration and continuous delivery, and the multiple delivery pipelines all are fundamentally enabled via microservices. With microservices, each team can independently roll out services at a faster pace, leverage the distributed architecture at its core, and also leverage the API contracts with which each services can talk to other service. So net basically, microservices and DevOps, go together when you talk about agility.
Yeah. And I think, on the other side of sort of the fence here, proverbial fence, the ability to implement the innovation flywheel when you are using microservices in conjunction with your developer practice really provides a pace to market from a business perspective that has been unseen or has not been seen, predominantly in software businesses, or perhaps even in consumer businesses like Amazon retail. That innovation will continue to accelerate if these practices are adopted within your developer teams.
All right. Well, I think there's a lot for people to definitely consider, and as they start moving and developing, the pace is accelerated, but I think the smaller teams and microservices really are helpful as opposed to large developments that kind of can get bogged down, and I think you definitely can improve your agility and go to market much faster now. And I think we're developing the security tools to make things safer for everyone. So
Correct.
Give you a moment. We do have a few minutes. If you have any final suggestions or words of wisdom before I go to the gift card winners, go ahead and speak up.
I'm looking forward to see who wins, so I'm okay if you move on.
All right, sounds good. And so the attendees selected for the $25 Amazon gift cards are Steve R,
Yes,
George G, Tom T, and Tan M.
Whoa.
And, you will all small short names today. You will receive an email at the email address you registered for this webinar. And if you're like me and you have like 7 different email addresses, you'll just have to wait and see which one it shows up at. And that email will explain how you can receive your gift. And if you don't receive it at one of your 7 emails, make sure you check your spam folder and see if it shows up there. I want to again thank Serge, Shakti, and Eric, our sponsors AWS and Sysdig, and you, our audience, for taking an hour out of your day to spend it with us. And goodbye, and may the fickle finger of fate be kind to you.
Very good, Charles. Thanks, everyone.
Take care, everyone. Thank you.
Bye. Thank you.